Good morning students. Today discuss exercise 7.2. Continuous second question. Show that give the determinant equal to 0. The determinant equal to 0. We have to prove LHS equal to RHS. RHS value is 0. Solution. Given LHS is determinant of B plus C, BC, B square, C square. The second row C plus A, CA, C square, A square. Third row A plus B, AB, A square, B square equal. We have to prove RHS value is equal to 0. Now, in second column is BC, CA and AB. In second column BC, CA, AB. BC, this time the element is not in A. This element is not in B. This element AB not in C. I take first row is multiplied by R1. First row is multiplied by A and the second row is multiplied by B and the third row is multiplied by C. Now, you can written R1, first row is multiplied by A, R1, and the second row is multiplied by B, and R2 is multiplied by B, R2, and the row 3 is multiplied by C, R3. First row is multiplied by A, second row is multiplied by B, and the third row is multiplied by C. First row is multiplied by A into B plus C is AB plus AC. AB plus AC. And the second one, ABC. Third one, B square, C square into A, B square, C square. And the second row is multiplied by B. Second row is multiplied by B, BC plus AB. BC plus A. And this one, A, B, C. Third one, B, C square, A square. Now third row is multiplied by C into A plus B. C into A plus B. AC plus B into C, BC. Next one, ABC. And third one, A square, B square, C. First row is multiplied by A and the second row multiplied by B and the third row is multiplied by C and each row multiplied by A, B, C. Now common set the value, divide by ABC. Every row multiply A, B, C. Common set the value is 1 by ABC. That is equal. And second column is ABC, ABC, ABC. ABC are common value. ABC common in C2. And next third column is also ABC. ABC is common. Now taking ABC common from C2 and C3. Taking ABC from C2 and C3. C2 and C3 taking ABC common from outside. This side ABC whole square. That is 2 times ABC whole square by ABC. Determinant of AB and first column AB plus AC. And second BC plus AB. This one AC plus BC. Take ABC is outside, remaining 1, 1, 1. ABC is outside, the remaining is A is outside, BC. Next one, CA. Third one, AB. Now ABC 1, ABC cancel. That is equal to ABC into determinant of this one. This determinant AB plus AC 1 BC, BC plus AB 1 CA, AC plus BC 1 AB. Now reduce the determinants AB plus AC. Now we can return the first column. C1 gives C1 plus C3. C1 plus C3. Now add the two columns C1 plus C3. C1 plus C3. AB plus AC plus BC. AB plus AC plus BC. And second column BC plus AB plus CA. Next BC plus AB plus CA. So on AC plus BC plus AB. So AB plus BC plus CA. And the second column same it as 1 1 1. And the third column as it is BC, CA and AB is equal. The first column is AB plus AC plus BC, AB plus BC plus CA, AB plus BC plus CA, AB plus BC plus CA is common, taking outside from column 1. ABC into AB plus BC plus CA into determinant of. This is common, taking outside the remaining 1 1 1 1 1 1 BC CA AB. The determinant is C1 is identical to C1 is identical to C2. C1 is identical to C2. Given the any two column are identical, given the determinant values is 0. So using the property, it is equal to ABC into AB plus BC plus CA, the determinant value equal to 0. Two columns are identical, the determinant values is 0. The total value equal to 0 into 0. It is RHS. To show that the result, given the determinant equal to 0, hence it is proved. Exercise 7.2. Third problem. Prove that given determinant equal to 4a square b square c square. The determinant equal to 4a square b square c square. Take LHS is determinant of a square bc ac plus c square. In second row a square plus ab b square ac. And third row ab b square plus bc c square equal to, given the determinant equal to 4a square b square c square. Now a square, first row is a square bc ac plus c square. Now cancel this value a square. Now I am taking r1 minus r2 minus r3. That is a square minus a square cancel, ab are cancel. Now taking the first row, we can return the first row r1 gives r1 minus r2 minus r3. r1 minus r2 minus r3. You using any way, or column wise or row wise anyone. Now I am taking r1, first row is r1 minus r2 minus r3. The first row is r1 minus r2 minus r3. This a square minus a square. This a square minus a square minus ab minus ab. This is r1 minus r2 minus r3. The first one. The second, bc minus b square. bc minus b square minus b square minus bc. And third one, ac plus c square minus ac minus c square. This r1 gives r1 minus R2 minus R3. And the second row as it is A square plus AB, B square and AC. And third row as it is AB, B square plus BC and C square. That is equal determinant of plus A square minus A square cancel, minus AB minus AB, minus AB minus AB is minus 2AB. Next one, minus BC plus BC cancel, minus B square minus 2B square. Next one, plus AC minus AC cancel. Next one, plus C square minus C square cancel. This value 0. And the second row as it is A square plus AB, B square, AC. Third row as it is AB, B square plus BC and C square. Now first row minus 2AB minus 2B square under 0. First row common, taking common value 2, taking outside 2 times half, that is equal 2 times half, 2 common, taking outside 2 into minus AB minus B square 0, and second row A square as it is A square plus AB B square AC, and third row AB B square plus BC C square. Now the determinant is, next one determinant is reduce the given the determinants. Next 2 times half the first row is as it is minus AB minus B square 0, and R2 you can return R2 A square plus AB. Add the 2 rows R2 plus R1 is plus AB minus AB cancel. Next one B square minus B square are cancelled. R2 gives R2 plus R1. You can return R2 is R2 plus R1. Adding the 2 rows A square plus AB minus AB cancel, that is A square. Next one B square minus B square cancel, this value is 0. Next AC plus 0 AC. And third row, now we can write R3 AB plus AB minus AB value is 0. This R3 plus R1. Adding the 2 rows, third row and the first row, R3 plus R1, AB minus AB value is 0. Next one B square plus BC minus B square plus B square cancel, the value BC. Next one C square plus 0, that is C square. The determinant is minus AB minus B square 0, A square 0 AC, 0 BC and C square. Expanding the determinants, expanding the determinant by row wise. The first one taking the element minus AB, column and row are eliminated, get the minor matrix 0 into C square BC AC. Next one minus B square, taking the element minus B square, column and row are eliminated, get the minor matrix A square AC 0 and C square. Next taking the element 0, column and row are eliminated, get the minor matrix A square A 0 and BC. Already you know expanding the row wise and column wise. Now that is equal 2 into expanding the row wise, 2 into first one taking the element minus AB into taking the element minus AB, column and row are eliminated, get the minor matrix 0 into C square. Multiply the diagonal, 0 into C square is 0, 0. Next formula is minus AC into BC. AC into BC is AB, C into C, C square, AB, C square, AB, C square. First one over. Next one, formula is minus, and the element is minus B square, minus into minus, plus B square. Taking the element B square this column and row are eliminated, get the minor matrix A square AC 0 and C square. Now value of this minor matrix A square C square. First multiply the diagonal A square C square. A square C square. Next one 0 into AC is 0 minus 0. Next one element is 0. Next one element is 0. 0 taking the element 0. 0 into anything value is 0. 0 into anything is 0. But the value is not defined. The value is 0. That is equal 2 into minus AB minus into minus plus. Minus into minus. Minus AB into 0 is 0. Minus into minus is plus. AB into ABC square. A into A square. A square. B into B square. And that is C square. C square. Plus B square A square. B square A square. C square is A square. B square. C square. A square B square 1 times of A square B square C square and 1 times of A square B square C square. Add the 2 terms. 2 times of A square B square C square. 2 into 2 times of A square B square C square. That is equal 2 to are 4 A square B square C square. That is RHS. To show that the result, take LHS equal to RHS. RHS value 4 into A square B square C square, hence prove. Next one, fourth question. Prove that given the determinant equal to ABC into 1 plus 1 by A plus 1 by B plus 1 by C. Now take LHS. LHS is 1 plus A 1 1 1 plus B 1 1 plus C equal. The first row is 1 plus A 1 1. Second row 1 plus B 1 and third row 1 plus C. Now reduce the determinant 1 plus A. Suppose R1 minus R2. 1 minus 1 is 0. Now taking any row. Suppose R1 minus R3. You taking any row. Now I am taking R1 gives R1 minus R2. R1 minus R2. This R1 gives R1 minus R2. The first row we can return R1 minus R2. 1 minus 1 is 0. 1 minus 1 is 0. The remaining 8. Next one 1 minus 1 0. Next minus B. Minus B. 1 minus 1 is 0. 1 minus 1 is 0. And the second row, now we can return, second row is R2 gives 1 minus 1, R2 minus R3, 1 minus 1 is 0. Next 1 minus 1, 0 into B. Next 1 minus 1 is 0. Now we can return R2 is, R2 gives R2 minus R3. R2 minus R3. 1 minus 1, 1 minus 1 is 0. Next 1 plus B minus 1 plus 1 minus 1 cancel, B. Next one 1 minus 1, 1 minus 1 cancel, minus C. And third row as it is 1 plus C. Now expanding the determinants. Now expanding the determinant by using row wise or column wise, anyone. Now expanding the row wise, A into the determinant A into, now taking the element A, column and the row are eliminate, getting the minor matrix B minus C 1 plus C. Now find the value of minor matrix. Now multiply the leading diagonal B into 1 plus C. B into 1 plus C is B into 1 B plus BC. First one taking the element A, this minor matrix B into 1 plus C is B plus BC. Formula is minus 1 into minus C, minus or minus plus C. The first one element is over. The next one, formula is minus, already the element is minus or minus plus B into, taking the element minus B, the column and the row are eliminate, getting the minor matrix 0, minus C, 1 plus C. 0 minus c, 1, 1 plus c. Now multiply the diagonal. 0 into 1 plus c is 0. 0 into 1 plus c is 0. Next one, 1 into minus c, already formula is minus, minus or minus is plus, plus c. Next one, 0. 0. So taking the 0, 0 into anything values is 0. That is equal. Now multiply this value. A is multiplied by this term. AB plus ABC, AB plus ABC plus AC plus B into 0 is 0. Next plus BC is equal. This term AB plus ABC plus AC plus BC. Now taking the common from ABC. Taking common from ABC. ABC into. Now taking ABC. AB divided by ABC 1 by C plus 1. Next plus 1 by B plus 1 by A. That is equal. Now we write in the form ABC into 1 plus 1 by A plus 1 by B plus 1 by C. That is RHS. To prove the result, ABC into 1 plus 1 by A, 1 by B, 1 by C. Hence it is proved. LHS equal to RHS. Next problem. Fifth one. Prove that secant square theta, the determinant value secant square theta, tan square theta 1, tan square theta, secant square theta minus 1, 38, 36, 2, given the determinant equal to 0. To prove the result, take LHS equal to RHS. RHS value 0. Now take the LHS value. LHS, the determinant of secant square theta, tan square theta 1, second row tan square theta, secant square theta minus 1, 38, 36, 2 equal to. Now we have to prove RHS value equal to 0. You know already trigonometric formula. Trigonometric formula, secant square theta minus tan square theta value 1. Secant square theta minus tan square theta value is 1. 38 minus 36 value 2. Tan square theta minus secant square theta value is minus 1. Now we can write this first column is secant square theta, tan square theta 38. First column we can return C1 minus C2. C1 minus C2 get the third column. Secant square theta minus tan square theta value 1. Is the first column. Write in first column. C1 gives C1 minus C2. C1 minus C2 first column. First column secant square theta minus C1 minus C2 secant square theta minus tan square theta. And the second one tan square theta minus secant square theta. Third one 38 minus 36. First column over. Second column as usual tan square theta, secant square theta 36, and third column as it is 1 minus 1 2. That is equal. Secant square theta minus tan square theta value 1. This value 1. Next tan square theta minus secant square theta. Taking minus outside, minus is common, taking outside secant square theta minus tan square theta, that is the value is minus 1. 38 minus 36, 2. And the second column as it is tan square theta, secant square theta, and 36. Third column 1 minus 1, 2. 1 minus 1, 2. Comparing the first column and the third column. Comparing the first column and the third column 1, 1. Minus 1, 2, 2. C1 is identical to C3. C1 is identical to C3. When the determinant any two column or row are identical, where the determinant value is 0. The determinant is 0. That is equal to 0. You have the determinant secant square theta, tan square 1, tan square theta, secant square theta minus 1, 38, 36, 2. value is 0. That is LHS equal to RHS. Hence, next problem. 6.1. Show that given the determinant equal to 0. LHS equal to RHS. RHS we have to prove equal to 0. Take LHS, given the determinant of x plus 2a, y plus 2b, z plus 2c. And the second row x, y, z, a, b, c equal to. By using the property 7, in each element of the determinant expressed sum of two or more terms, the whole determinant expressed sum of two or more determinants. By using the property 7, x plus 2a, the express the determinant is, the first determinant is x, taking the x, the first one, taking the first row is x, y, z. And the second row x, y, z. And third row a, b, c as usual. The first row is x, y, z. And the second row x, y, z. And third row a, b, c plus 2a, 2b, 2c is the second determinant, plus 2a, 2b, 2c in right in first row, and the second row as it is x, y, z, and third row a, b, c. The first determinant is the first row x, y, z, and the second row x, y, z. Comparing the two rows x, y, z and x, y, z. First row and second row are identical. First row, second row are identical. But the determinant values is 0. That is, the determinant is 0. R1 is identical to R2. R1 is identical to R2. The determinant, the determinant any two row, any column are identical, then the value is 0. Plus, next one. The determinant 2a, 2b, 2c. Comparing the third row is a, b, c. Using the property, any row a, b, c multiplied by a scalar, another row, the same value. Now taking the common value 2, the first row is common from 2 taken outside, a, b, c, x, y, z, a, b, c. Now comparing the two rows R1 and R3. R1 and R3 are identical. ABC value. R1 is identical to R3. That is, the determinant value is 0. That is 0 plus 0. 2 times of 0 is 0. It is equal to 0. To prove the result, equal to 0. Next problem. 7th one. Write the general form of a 3 by 3 skew symmetric matrix and prove that determinant is 0. The general form of 3 by 3 skew symmetric matrix. Skew symmetry. Already you know skew symmetric matrix. A transpose equal to minus A is a skew symmetry. In general form of a skew symmetric matrix is, this is the matrix A equal to the general form of a skew symmetric matrix in 3 by 3. Order is 3 by 3 matrix. Skew symmetric matrix is the diagonal values is 0. Diagonal value is 0. Diagonal is 0. A, B, taking the element A, B, the same element as it is, sign only change, minus A. The element is C, that is minus B, minus C, is the skew symmetric matrix in general form. Skew symmetric matrix. Skew symmetric matrix is the diagonal value is 0. This element is opposite sign in the elements. That is a skew symmetric matrix. Now we have to prove the skew symmetric matrix is the determinant value is 0. We have to prove the determinant equal to 0. Now find the determinant. Given the matrix is A, now find the determinant. Determinant of A equal to determinant of 0, A, B, minus A 0 C minus B minus C 0. That is a determinant A. Now find determinant A equal to expanding row wise or column wise. Anyone expanding the determinant, taking the element 0, 0 into taking the element 0, column and row are eliminating, get the minor matrix. 0 into 0 is 0. Minus, formula is minus C into C plus C square. 0 into anything also 0. Next one, minus. First two taking plus minus plus. Next one, formula is minus A into this column and row are eliminate, getting the minor matrix minus A, C, minus B, 0. Now multiply the leading diagonal, minus A into 0 is 0. Next one, formula is minus B into C minus BC, also plus minus into minus plus BC. Next one, plus B into this element, B well, taking the element B, column and row are eliminate, getting the minor matrix minus A 0, minus B minus C. Now multiply this value, minus A into minus C, minus into minus plus, A into C, AC. This is AC. Next one, minus B into 0 is 0. Is equal to 0. 0 into anything, 0. 0 into anything, 0. Next one, minus A into 0 is 0. Next one, minus into plus, minus A into BC is ABC. ABC. Next one, plus B into AC is plus ABC. Plus ABC minus AB is equal to 0. That is the determinant value equal to 0. Next problem, 8th one. If the determinant equal to 0, the determinant equal to 0 given, prove that A, B, C are in GP. A, B, C are in GP, or alpha is the roots of AX square plus 2BX plus C equal to 0. Given the determinant equal to 0, we have to prove A, B, C are in GP, or alpha is the roots of this equation. Now taking given determinants, determinant of A, B, A alpha plus B, and the second row B, C, B alpha plus C. Next one, A alpha plus B, B alpha plus C, 0 equal to 0. Given the determinant equal to 0. Now expanding the determinants. You taking row wise or column wise. You taking the row wise first row, second row or third row, any one row, or taking column wise first column, second column or third column, any one, using anyway method. Now I am taking on third row, the reduce the determinant A alpha plus B, B alpha plus C. Now write the third row is A alpha plus B. Suppose R3 minus R2. Now write the third row A alpha plus B, R3 minus R2 plus B minus B cancel. That is A alpha, suppose R1, R3 minus R1, A alpha, this element is A only. Now multiply, the first row is multiplied by alpha. Now we can write R3, row 3 gives, first row is multiplied by alpha. Is R3, we can return in the R3. R3 gives R3 minus alpha R1 minus R2. So we can write R3 minus alpha R1 minus R2. This is the determinant. The first row is as it is A, B, A alpha plus B. A alpha plus B. Right in first. And the right in second row as it is B, C, B alpha plus C, B alpha plus C. And the third row is R3 minus alpha R1 minus R2. R3 minus alpha R1, A alpha plus B minus A alpha. A alpha minus A alpha cancel. Next one, B minus B are cancelled. That is R3 is A alpha plus B minus alpha R1. R1 is multiplied by alpha, A alpha minus A alpha. Next one, minus B. And the second element. B alpha plus C minus B alpha minus C. And the third one, 0 minus is equal 0 R3 minus multiplied by alpha is R1 minus multiplied by alpha, A alpha square, next one minus B alpha minus B alpha, that is minus B alpha minus C equal to 0. That is the third row. Third one is 0 minus alpha R1 minus R2, 0 minus of B alpha square minus B alpha minus C, that is 1. This is equal to first row as it is A alpha plus B. Second row as it is B alpha plus C, B alpha plus C. And the third row, A alpha minus A alpha cancel, A alpha minus A alpha cancel, plus B minus B cancel, the value is 0. Next one, B alpha plus B alpha minus B alpha cancel, plus C minus C cancel, that is the value is 0. Next one, minus E alpha square minus B alpha minus C, taking minus common, minus of A alpha square, plus minus B alpha minus 2B alpha, minus is common, 2B alpha plus C equal to 0. Now reduce the determinants. Equal. Now expanding the determinants. Taking row wise or column wise. Now I am taking the row wise R3, expanding the R3 wise. R3 is 0. First one taking the element 0. 0 and anything values is 0. Next element is 0. 0 and anything values is 0. Next one E alpha square, taking the element, this column and row are eliminated, getting the minor matrix. Now I am taking to easy way, expanding the R3. First one, 0 element is 0 and anything is 0. Plus 0 and anything is 0. Next one element is minus of A alpha square plus 2B alpha plus C into, taking the element, this one, column and row are eliminate, getting the minor matrix. Find the value of minor matrix is A, B, B, C. Now multiply the diagonal AC. Formula is minus B into B, B square equal to 0. That implies minus of A alpha square, that is multiplied by minus A alpha square plus 2B alpha plus C into AC minus B square equal to 0. Getting the two factors, two values. First one equating 0. A alpha square, that is implies A alpha square plus 2B alpha plus C equal to 0, first one, and the second one AC minus B square equal to 0, is the second one. First one result A alpha square plus 2B alpha plus C equal to 0, AX square plus 2BX plus C equal to 0. AX square plus 2BX plus C equal to 0. Here alpha is the roots of this equation, therefore alpha is the root of the equation. AX square plus 2BX plus C equal to 0. Prove the first one result. Prove that the result is alpha is the roots of AX square plus 2BX plus C equal to 0. That is the first one answer. And the second one, A, B, C are in GP. We have to prove that A, B, C are in GP. So the second one result, A, B, C are in GP. Given the condition AC minus B square equal to 0, AC minus B square equal to 0, that is AC equal to B square. AC equal to B square. That is AC equal to B square is multiple of 2 times. B into B is B square. Now B decide C by B equal to B by A. C by B equal to B by A. Already you know GP T3 by T2 equal to T2 by T1 or T2 by T1 equal to T3 by T2. That is A, B, C are in GP. T3 by T2 equal to T2 by T1. Common ratio are equal given the terms are GP. Therefore, A, B, C are in GP. That is A, B, C are 3 terms. T1, T2, T3. T1, T2, T3. T2 by T1 is B by A. Next one, T3 by T2 is C by B. Common ratio are equal given the terms A, B, C are in GP. Next problem, 9th one, prove that given determinant equal to 0. We have to prove equal to 0. Taking the determinant 1, first column 1, 1, 1. Second column A, B, C. Third column A square minus BC, B square minus CA, C square minus AB. This equal to, this determinant is the third column A square minus BC, B square minus CA, C square minus AB. Now we express the two determinants. Expand the express the two determinants. The first determinant is, the first column is as it is say 1, 1, 1. And the second column A, B, C, and third column A square, B square, C square. A square, B square, C square. This minus. Subtract this value, minus. The second determinant is 1, 1, 1 first column, and the second column A, B, C, and third column B, C, CA, AB is the third column. And is equal. The given the determinant is as it is same 1A square, 1B square, 1C square minus. So the determinant is 1A 1B CA, 1C AB. The third column is BC CA AB. Now the first row is multiplied by A. First row is multiplied by A square ABC. And the second column is multiplied by B square ABC. And the third column is multiplied by C square ABC. ABC common taking outside. Now multiply of First row is multiplied by A, second row multiplied by B, and the third row multiplied by C. First row R1 gives multiplied by A, and R2 multiplied by B, and R3 multiplied by C. First row is multiplied by A square, ABC. Next one, second row is multiplied by B square, ABC. And third row, C multiplied by C is 1 into C into C square, and ABC. Now each row is multiplied by ABC, and common set the value, divide by ABC, 1 by ABC, divide by ABC. Now taking ABC common from C3, taking outside. The second, that is equal, the determinant 1A square, 1B square, 1C square minus 1 by ABC is determinant of A square ABC. And third column ABC is common. Taking ABC common from C3 is ABC taking outside. ABC. The first column is A, B, C. The second column A square, B square, C square. ABC is taking outside with the value 1, 1, 1. 1, 1, 1. This ABC gets cancelled. This equal, given the determinant is 1A square, 1B square, 1C square minus, given the determinant is A square, B square, C square, 1, 1, 1. Now interchanging the columns. Any interchanging column, any two row or two columns are interchanging, the determinant is changes from only sign. Sign only change. Sign only change is minus, minus of minus is plus. Two rows are interchanged, any two row or columns are interchanged, then the determinant is changed only sign. That is the determinant A, B, C. C3 is replaced in C2, 1, 1, 1. And the third column A square, B square, C square. This equal, determinant is 1A square, 1B square, 1C square. Next one, plus. Next one, given the determinant 1A square, 1B square, 1C square. This determinant is ABC, 1, 1, 1, A square, B square, C square. Now, replace the column 1 and column 2. Interchanging the column 1 and column 2. Given the determinant, interchanging any two row or columns, only sign only change. That is minus. Interchange the row. 1, 1, 1. A, B, C, A square, B square, C square. Interchanging row is C1, interchanging C2. This one is C2, interchange C3. Get the 1A square, 1B square, 1C square minus of 1A square, 1B square, 1C square. The answer is 0. Next problem. 10th one, if A, B, C are P, Q and rth term of an AP. A, B, C, A is pth term, B is qth term and C is rth term of an AP. Find the value of this determinant. What is given? A is pth term, B qth term, C is rth term of an AP. Already you know AP formula, Tn formula. The nth term formula Tn equal to A plus n minus 1 into D. This is the formula. Here A is pth term. A equal to pth term is Tp. Tn formula. Tn formula Tn equal to nth term formula Tn equal to A plus n minus 1 into D. Nth term formula. When P Tp A plus, here A is capital using capital A plus n minus 1 P minus 1 into D using capital D. Here A value A equal to A plus P minus 1 into D. Next one, C is qth term. B is qth term. B equal to TQ equal to TQ. Same A plus n minus 1 D is, here n is Q minus 1 into D. Next C value equal to rth term. Rth term is A plus R minus 1 into D. R minus 1 into D. A value A plus P minus 1 to D. B value A plus Q minus 1 to D. C equal to A plus R minus 1 into D. Now find the value of this determinant. Find the value of this determinant. This is a determinant A, B, C, P, Q, R 1, 1, 1. This is equal to, here A value is, here A already find A equal to A plus P minus 1 to D. Here A value A plus P minus 1 to D. Substitute the values. Here A value A plus P minus 1 into D. Next B value, B is A plus Q minus 1 into D. Here B value. C value A plus R minus 1 into D. R minus 1 into D. The P, Q, R as it is same, the second row P, Q, R, and the third row as it is 1, 1, 1. The first one is A plus P minus 1 into D, A plus Q minus 1 into D, A plus R minus 1 into D. By using the property 7, each element of the determinant sum of 2 or more terms, the whole determinant is expressed as sum of the determinants. Here expand the determinants is equal. The expand the determinants, the first determinant is the first element A. First one A. First row is A. And the second row, first one A. And the second row is P, Q, R. Third row 1, 1, 1 plus. Expand the determinants. Next one P minus 1 into D, Q minus 1 into D, R minus 1 into D. Next one, the determinant P minus 1 into D, P minus 1 into D, Q minus 1 into D, R minus 1 into D is right in a first row. The second row as it is P, Q, R. Third row as it is 1, 1, 1. That is equal. First row A. The first row every element has the common from A. Taking outside A into 1, 1, 1. P, Q, R 1, 1, 1. Plus. Next one, P minus 1 D, Q minus 1 D, R minus 1 D. D is common. Taking R1. D into P minus 1, Q minus 1, R minus 1. The second row P, Q, R. Third row as it is 1, 1, 1. Is equal A into 1, 1, 1, 1, 1, 1. Comparing the R1 and R3, two rows are identical. The determinant value is 0. R1 identical R3, R1 identical R3, the determinant value is 0. Plus D into this one, D into the determinant P minus 1, Q minus 1, R minus 1. P, Q, R, 1, 1, 1. Now, the first row is, now we can return first row, R1 gives R1 plus R3. R1 plus R3. R1 plus R3, P minus 1 plus 1 plus 1 minus 1 cancel. Q minus 1 plus 1 plus 1 minus 1 cancel. R minus 1 plus 1 minus 1 cancel. Getting P, Q, R. P, Q, R. And second row P, Q, R. And third row 1, 1, 1. This A of 0 is 0. 0 plus D into PQR, PQR. First row and second row. R1 and R2. Comparing the two rows R1 and R2. R1 is identical to R2. Given the determinant is, the value is 0. Given the determinant is 0, it is 0. 0 plus D of 0 is 0. 0 plus 0 is 0. Therefore, the value of determinant is equal to 0. Next problem, 11th one. Show that given determinant is divisible by x power 4. Divisible by x power 4. Given the determinant is, taking the determinant of a square plus x square, AB, AC, first row. Second row, AB, B square plus x square, BC. And third row, AC, BC, C square plus x square. Now, the first row is multiplied by A, and second row multiplied by B, and the third row multiplied by C. I am taking first row is multiplied, R1 is multiplied by A, and R2 is multiplied by B, and R3 is multiplied by C. First row is multiplied by A. The first row multiplied by A into A square plus x square. And this one, A square B. Next one, A square C. First row is multiplied by A. And the second row is multiplied by B. A B square. B into B square plus x square. B square plus x square. Next one, B into BC is B square C. And third row is multiplied by C. A C square. Next one, B C square. C into C square plus x square. The first row multiplied by A, second row multiplied by B, third row is multiplied by C. Common set the value is divided by ABC. Divided by ABC. And is equal to 1 by ABC given the determinant. The first column A into A square plus x square, AB square, AC square. The second column A square B, B into B square plus x square, BC square. And third column A square C, B square C, C into C square plus x square. Now taking A, B, C, first column in A taking outside A, and the second column B and third column C. Taking A, B, C, taking C1, C2, C3. Taking A, B, C, common from C1, C2 and C3. So this A, B, C. This first column taking element A, and the second column common from B, and the third column is common from C. ABC by ABC. Common from A value A square plus x square, first column. Next one B square. A is taking outside, B square. Next one A is common outside, the remaining element is C square. The first column over. The second column taking B outside, the remaining element a square, next one b square plus x square, b square plus x square, next one c square. And third column, common from c, taking outside, remaining a square, b square, and c square plus x square, c square plus x square. Now ABC by ABC are let's cancel. That is equal to determinant of the remaining a square plus x square, a square, a square. Next one b square plus x square, b square, and c square plus x square, c square plus x square. Now reduce the determinant. Suppose a square minus a square. Reduce the determinant. A square minus a square value is 0. The first column is same as a square plus x square, b square, c square. And the second column, C2 gives C2 minus C3. C2 minus C3. C2 minus a square value 0. Next one b square plus x square minus b square plus b square minus b square cancel, the value x square. Next one c square minus c square minus x square, c square minus c square cancel, c square minus c square cancel, remaining minus x square. And C3 is C3 gives C3 minus C1, C3 minus C1, a square minus a square minus a square is a square minus a square 0 minus x square, b square minus b square value 0, c square plus x square minus c square minus c square cancel with the x square. Your determinant a square x square 0 minus x square, b square x square 0, c square minus x square. Now expanding the determinant row wise or column wise, anyone. Now taking row wise, expanding the determinant, first one taking the element a square plus x square, taking the element a square x square, column and row are eliminate, get the minor matrix x square 0 minus x square. Now multiply the leading diagonal, x square and x square is x power 4, x square and x square is x power 4. Next one 0 to anything, values is 0, that is 0 plus 0. Next one taking the element is 0 plus 0 or minus 0, formula is minus 0 to anything is 0. 0 to anything values is 0. Next element is minus x square into, taking the element minus x square, column and row are eliminate, getting the minor matrix b square x square, c square minus x square. Now multiply this value, b square minus x square is minus b square x square, formula is minus c square x square, c square into x square, c square into x square, c square x square. Now multiply this value. First one a square into x power 4, a square x power 4 plus x power 4 into x square is x power 6, x square into x power 4 is x power 6. X is 0 to anything 0. So 0. Next one minus of x square minus of minus b square x square, multiply minus and minus is plus. Minus and minus is plus x square into x square x power 4 b square, x power 4 b square. Next one minus and minus plus, minus and minus is plus x square and x square is x power 4 c square, x power 4 c square. A square x power 4 plus x power 6 x power 4 b square plus x power 4 c square. Now x power 4 is common. All the terms are x power 4 common. Taking outside, x power 4 into the remaining a square plus x square plus b square plus c square. This x power 4 into a square plus x square plus b square plus c square. This is our multiple of x power 4. Multiple of x power 4 is also a divisible of x power 4. This value is, therefore, this value is divisible by x power 4.